11:47 on a Tuesday night. A guy I've known for years calls me. His 2013 Ford Escape is running like garbage. Idles rough at every stoplight. Gas mileage dropped from 24 to 17 in 2 weeks. Takes 3 tries to crank in the morning. He just got back from a chain shop that quoted him $1,400. Throttle body cleaning, fuel injector service, new spark plugs, MAF sensor replacement. $1,400. I told him to pop the hood, find his battery, and grab a 10mm wrench. 20 minutes later he called me back. The car was running like the day he bought it. Total cost, $0. Total tools. 1 wrench he already owned. And the procedure I walked him through is something Ford engineers wrote into the service manual themselves. The dealer's not going to mention this. Here's what nobody tells you about modern cars. Every engine built after about 1996 has a computer running it. That computer doesn't just read sensors and spit out fuel commands. It learns. It builds a memory of how your engine behaves and adjusts itself accordingly. That memory is called adaptive learning, and inside it there are values called fuel trims, idle correction tables, throttle position offsets, and a whole stack of other adjustments the computer makes on the fly to keep your engine running smooth as it ages. The problem is, that memory can go bad. Just like your phone slows down after 2 years of background apps building up, your engine computer can fill up with corrupted learned values. And when those values get bad enough, your car starts running like garbage even though every single physical part is fine. I'm going to show you a procedure that takes 90 seconds of actual work, costs nothing, requires no scan tool, and resets that memory completely. It fixes rough idle. It fixes hard starts. It fixes random check engine lights. It fixes that mysterious drop in gas mileage that nobody can explain. And there's a specific reason most people who try this still don't get it to work properly, which I'll get to in a few minutes. Because doing the disconnect wrong is worse than not doing it at all. Let me tell you what's actually happening inside that computer. Your engine has sensors everywhere. Oxygen sensors in the exhaust, mass airflow sensor on the intake, coolant temperature sensor, throttle position sensor, crankshaft position sensor, cam position sensor, knock sensor, manifold absolute pressure sensor. On a modern car, you've got somewhere between 15 and 30 sensors all feeding data into the engine control unit 100 times a second. The computer takes all that data and compares it to a base map programmed at the factory. But the factory map is generic. It was written for a brand new engine running on perfect gas at sea level on a 70-degree day. Your engine isn't that. Your engine has 80,000 miles on it. Your engine has carbon buildup. Your gas has 10% ethanol. You live in Denver at 5,000 feet of elevation. Or you live in Phoenix where it's 115 in the summer. The computer compensates for all of that by learning. Every time you drive, the computer compares what it expected from the sensors to what it actually got and adjusts. If the oxygen sensor says the mixture is too lean, the computer adds a little more fuel next time. If the idle drops when the AC kicks on, the computer learns to bump the idle up a bit when the compressor engages. These adjustments are stored in 2 memory locations. The first is called short-term fuel trim, which resets every key cycle. The second is long-term fuel trim, which sticks around. That long-term memory is where the trouble lies. Think of long-term fuel trim like the autocorrect on your phone. The first time you type a weird word, your phone learns it. Helpful, right? Now imagine you spend 3 months typing drunk at 2 in the morning. Your autocorrect is broken. Every word it tries to suggest is wrong. The phone hardware is fine. The software is fine. But the learned dictionary is poisoned. That's exactly what happens to your engine computer. A bad tank of gas, a dirty mass airflow sensor that you eventually cleaned, an oxygen sensor that was slow before you replaced it, a vacuum leak that's been fixed, but the computer's still compensating for it. All of that ends up baked into the long-term memory. I noticed this after seeing it happen 30-something times. Customer comes in with a rough idle. We fix the actual problem. The car still runs rough. Why? Because the computer's still compensating for the problem we already fixed. It needs to forget what it learned and start over. Here's the procedure. And listen carefully because the part everyone gets wrong is in the middle. Park the car on a level surface. Engine off. Key out of the ignition. If you have a key fob, take it inside the house because some cars stay partially awake as long as the fob is within range. Pop the hood. Find the battery. On most cars, it's in the engine bay. On some newer Fords, BMWs, and Mercedes, it's in the trunk or under the rear seat. Doesn't matter where it is. You need to get to the negative terminal. It's marked with a minus sign and usually has a black cable. The positive terminal has a plus sign and a red cable. Do not touch the positive. You're only working with the negative. Take a 10mm wrench. On some European cars, it's a 13mm. Loosen the nut on the negative terminal clamp. You don't need to remove the nut completely. Just loosen it until the clamp can be lifted off the battery post. Lift it off. Move the cable to the side so it can't accidentally touch the terminal. And now the most important part, the part that 90% of people get wrong. Wait. Just wait. Not 30 seconds. Not 2 minutes. A real 10 minutes. I'd actually recommend 15 on anything built after 2015. Set a timer on your phone. Walk away. Get a coffee. Do not touch the car. Here's why. When you disconnect the battery, the engine computer has a backup. It's called Keep Alive Memory, and it's powered by capacitors inside the ECU itself. Those capacitors can hold a charge for several minutes after the battery is disconnected. If you only disconnect for 1 minute, you've drained the short-term trims, but the long-term memory is still intact. You did nothing. The car will feel the same when you reconnect. Most people try this trick. Leave the battery off for 2 minutes because some guy on a forum said 2 minutes is enough, and then complained that it didn't work. It didn't work because the capacitors were still feeding the memory chip. 10 minutes is the minimum to guarantee full discharge on most domestic cars. 15 minutes is safer on European cars and anything with a complex body control module. I've seen 2018 and newer Volkswagens that needed a full 20 minutes because they have so much electronics tied into the Keep Alive circuit. While you're waiting, here's a useful trick. Press the brake pedal a few times with the battery disconnected. This drains any residual voltage in the brake light circuit and helps bleed off the capacitors faster. Some people swear by holding the headlight switch on for 30 seconds. Doesn't hurt. Probably helps on stubborn systems. This isn't theory. This is what the manufacturers themselves tell their technicians to do. There's a service bulletin from General Motors, TSB number 02-6A4-37, that specifies a minimum disconnect time of 2 minutes for fuel trim reset and 10 minutes for full module relearn. Toyota's repair manual for most models from 2007 onward specifies 15 minutes. Ford's TSB on idle relearn procedures says 10 minutes minimum, 15 recommended. The dealer technicians read these documents. The service writer at the front counter does not. So when you come in complaining about a rough idle, the service writer sells you a $1,400 diagnostic package because that's what the computer screen in front of them suggests. The tech in the back could fix it in 90 seconds, but the tech doesn't write the estimates. While we're waiting for those 10 minutes, let me tell you why this even became necessary in the first place. Cars before about 1995 had what was called open-loop fuel injection most of the time. The computer ran off a fixed map. It barely learned anything. You couldn't really reset it because there was nothing to reset. Then came OBD-DECAN in 1996, mandated by the Environmental Protection Agency to reduce emissions. To meet those tighter emissions standards, manufacturers had to make engines that constantly adjusted themselves. The adaptive learning system was born out of regulation, not consumer demand. The result is an engine that runs cleaner and gets better mileage when everything's working right, but also an engine that can develop electronic neuroses that have nothing to do with the actual hardware. The other thing that made this worse was ethanol-blended gasoline. In 2005, the Energy Policy Act started mandating ethanol blending. Most of the gas you buy now is E10. 10% ethanol. Ethanol burns differently than pure gasoline. It has different oxygen content, different vapor pressure, different combustion characteristics. The computer learns to compensate, but ethanol content varies from station to station, season to season, batch to batch. Your computer is constantly trying to hit a moving target, and sometimes it overcorrects and gets stuck. A reset wipes that overcorrection and lets it learn fresh. Okay, 10 minutes has passed. Now we reconnect. Put the clamp back on the negative terminal. Tighten the nut snug, not gorilla tight, just firm enough that you can't twist the clamp by hand. Now here's the second part that most people skip, and this is what separates a partial reset from a full relearn. Do not start the car yet. Sit in the driver's seat. Insert the key. Turn it to the on position, not start. You'll hear the fuel pump prime for 2 or 3 seconds. Wait until it stops. Then turn the key off. Wait 5 seconds. Turn it back to on. Listen for the fuel pump again. Turn it off. Do this 3 times total. What you're doing is letting the computer wake up, take stock of its sensors, and verify all its baselines before you make it try to control combustion. Skipping this step is why some people do the disconnect and then complain that the car ran worse for a week afterward. It ran worse because they fired it up cold with the computer having no baseline data. After the third key cycle, start the engine. Don't touch the gas. Just turn the key to start and let it crank. The engine will probably idle weird for the first 30 seconds. It might hunt up and down between 700 and 1500 RPM. That's normal. The computer is learning your idle air control valve from scratch. Let it idle for at least 5 minutes without touching the gas pedal. Just sit there. If you have air conditioning, leave it off. If you have the radio on, turn it off. You want no electrical load besides the basics. The engine needs to find its happy place at idle with nothing distracting it. After 5 minutes of idle, turn the AC on. Let it idle another 2 minutes. The computer needs to learn the idle correction for AC compressor load. Turn the AC off. Turn the headlights on. 2 more minutes. Now you've taught it how to handle electrical load. Now drive it. But here's where most people screw up the relearn. They drive it like they normally do, which means starting up, going to the highway, cruise control, and they wonder why the car still feels weird 3 days later. The computer relearns through specific driving conditions. You need to give it a variety of inputs. Drive and stop and go for at least 15 minutes. Get it up to about 30 miles per hour and let off the gas completely. Let the car coast down to a stop. Do that several times. Then take it on the highway, get up to 65, and hold steady cruise for 10 minutes. Then take an off-ramp, decelerate, come to a stop. Then accelerate hard back to highway speed once. Just once. You don't need to race. You just need to give the computer one wide-open throttle data point so it can learn the upper end of the map. The full adaptive relearn cycle takes about 100 miles of mixed driving on most cars. After the first 30 miles, 90% of the trims have settled. By 100 miles, you're locked in. You'll feel the difference. The throttle response sharpens. The idle smooths out. The gas mileage often comes back up by 2 or 3 miles per gallon on cars that had drifted bad. Hard starts go away because the computer has a clean coolant temperature compensation table. Toyota does this slightly differently than Ford. Toyota's idle relearn requires the engine to reach full operating temperature, which is 120 cycles between the radiator fan kicking on and shutting off. If you do the disconnect and then only drive for 5 minutes, the Toyota never gets the chance to complete its relearn. You need a solid 20 to 30 minute drive that includes letting the engine fully warm up. Honda is more forgiving. Honda's K-Series and L-Series engines, which cover most Civics, Accords, CR-Vs, and Odysseys from 2003 onward, complete their idle relearn in about 3 to 5 minutes of steady idle after reconnection. GM is somewhere in the middle, with most LS platform V8s and Ecotec 4-cylinders completing relearn within 10 to 15 minutes of normal driving. You won't find this in the owner's manual. The owner's manual tells you nothing about adaptive learning. The owner's manual tells you to change the oil and check the tire pressure. The actual procedures are in the technician service manuals, which dealers buy for thousands of dollars a year per franchise, and which most customers never see. Let me tell you about a 2015 Chevy Silverado 1500 that came through my shop in 2019. Customer had spent $2,300 chasing a rough idle problem. He'd had 2 oxygen sensors replaced. He'd had the throttle body cleaned. He'd had the intake manifold gasket replaced. Nothing fixed it. Came to me as a last resort before he traded the truck in. I drove it. It idled rough. I pulled codes. There were no codes. I looked at live data. The long-term fuel trim was sitting at plus 18% on bank 1 and minus 6% on bank 2. That meant the computer was dumping fuel into one side and pulling fuel from the other, trying to balance out a problem that had been fixed 2 months earlier when the original tech replaced the first oxygen sensor. The trims never got reset. They got locked in. I disconnected the battery for 15 minutes, did the key cycle procedure, started it up, let it idle, drove it for 40 miles. The trims came back to plus 2 and plus 1, where they should have been all along. The truck ran perfect. I charged him $110 labor for the diagnostic time. He drove off shaking his head. That's the thing that still gets me about this industry. The reset itself takes 90 seconds. The waiting takes 15 minutes. The drive cycle takes an hour. But the diagnostic to know that the reset is what's needed. That requires looking at live data and recognizing a pattern. And patterns are what techs at chain shops are not paid to look for. They're paid to swap parts. A note on what this won't fix. This is not a magic cure. If your car has an actual mechanical problem, a reset won't help. A dragging brake caliper that's killing your gas mileage is still a dragging brake caliper after the reset. A leaking intake manifold gasket is still a leaking intake manifold gasket. A worn-out spark plug is still a worn-out spark plug. What the reset fixes is the residue of past problems. The learned compensation that's still hanging around after the underlying issue went away or after a part was replaced. It also helps when you've made changes to the car that the computer needs to relearn around. New air filter that flows differently than the old clogged one. New cold air intake. New exhaust. Switching gas brands or octane levels. All of these can throw the trims off, and a reset gives the computer a fresh start. There's a related procedure that's worth mentioning. The idle air control valve relearn. On older cars from about 1995 to 2010, there's a physical valve called the idle air control valve, abbreviated IAC, that controls how much air bypasses the throttle plate at idle. This valve gets carbon buildup over time. When it's dirty, the computer learns to keep it more open than normal to maintain idle. Then, if you clean the valve without resetting the computer, the engine idles too high because the computer's still telling it to bypass too much air. On these cars, the battery disconnect resets the IAC position memory and lets it relearn the correct opening. Newer cars from about 2008 onward use what's called electronic throttle control, where there's no separate IAC valve. The throttle plate itself moves to control idle. These cars need a slightly different procedure. After the battery reconnect, with the engine off, slowly press the gas pedal to the floor and release it 3 times. This calibrates the throttle position sensor. Then start the engine. This is what's called pedal position relearn, and it's required on most Chrysler, Dodge, Jeep, and Ram vehicles from 2008 onward, plus a lot of Mercedes products. I used to believe the dealer line about needing a scan tool for every reset, until I figured out that 90% of what a dealer scan tool does on a basic relearn is exactly what the battery disconnect does, except the scan tool has a button labeled fuel trim reset, and the disconnect requires you to know what you're doing. The scan tool also typically resets the keep alive memory by sending a software command instead of forcing a hardware disconnect. The end result is identical: reset memory, new baseline, fresh start. Now some 2020 and newer cars have what's called persistent memory storage. Volkswagen, Audi, some BMW models, and most newer Mercedes have memory that survives a battery disconnect. On these cars, you actually do need a scan tool to force the reset because the memory is stored in non-volatile flash and doesn't depend on capacitor backup. If you have a 2020 or newer European car, this procedure may not do anything. For everything else built between 1996 and roughly 2020, this procedure works. Here's another thing worth knowing. Some people worry about losing radio presets, clock settings, and so on. Yes, that happens. Your radio will need to be re-entered if it has an anti-theft code, and most modern radios don't anymore. Your clock will need to be set. Power window auto-up function may need to be reinitialized on some cars, which usually means holding the window button up for 2 seconds after it reaches the top. Sunroof auto-close may need the same. Trip odometer will reset on some cars but not others. These are minor inconveniences. The real concern with newer cars, anything from about 2015 onward, is that the throttle body itself may need a more involved relearn that includes the gas pedal calibration I mentioned earlier. If after this procedure your car has a rough idle that won't settle after a full drive cycle, that's usually the cause. 3 pedal presses to the floor with the key on, engine off, fixes it. The reason this all matters comes down to a basic math problem. The average rough idle diagnosis at a chain shop runs between $400 and $1,200 in parts and labor. The average misdiagnosis rate, in my experience, is somewhere around 40%, which means almost half the time, the customer is paying for parts that didn't need replacing. A battery reset costs nothing and resolves an estimated 20 to 30% of rough idle, hard start, and poor fuel economy complaints on cars between 5 and 15 years old. Do the math. Most drivers will never figure this out. They'll keep paying for diagnostics that find nothing, paying for parts that didn't need replacing, paying for service packages designed to make next year's repair more profitable. The disconnect doesn't fix everything, but it costs nothing to try. And it's the first thing I do on every weird drivability complaint that walks in, before I plug in a single piece of equipment. Because if the problem goes away after the reset, the problem was never the part. The problem was the memory of a part that's already gone. My buddy with the 2013 Escape called me again last week, 40,000 miles after that 15-minute fix. The Escape's still running fine. He's still got the $1,400 in his pocket. And he's the one who told me I should make this video. If you want more of what the dealer won't tell you, you know where to find me.